Abington Junior High School, welcome to another episode of Whether You Like It or Not. Parents and students of Mr. Fogel, Mr. Steinhardt, Mr. Traver, Mr. Keller, and Mr. Sharp. Did I forget anybody? Welcome to this episode. We have some very special guests with us today. We have Tim Brice, Patrick Hyland, and Trent Davis. They will introduce themselves momentarily, and we'd like to get going. So we're covering the topic of meteorology and specializing in storms and forecasting and nor'easters and hurricanes this coming week. So we thought we'd bring in some of the best, the most distinguished meteorologists that the National Weather Service and the Storm Prediction Center has. So guys, welcome. Thank you very much.
It is our pleasure to be joining you guys today. We're looking forward to it. What I'm going to do for you guys today is I'm going to give a very short presentation. I'm going to introduce my coworkers here because we're actually scattered all across the country, and I'll show you guys on a map where we're all located. I'll give a short talk on what our jobs are and a few of the tools that we use. And then I'll go over, when we do this, I go over a current weather briefing. And I know you guys are going to be watching this kind of tape delayed kind of thing, but we're not using tape. And but it'll give you an idea of some of the weather maps, what they look like and things like that. And I hope you just get you a taste for what it is to be a forecaster. But like Mr. Morgan mentioned, I am Tim Brice, and I am a meteorologist. I work in the National Weather Service office in El Paso, Texas, so it's way out in West Texas. Also joining me on the call with you guys today is Mr. Pat Hyland. He's a research meteorologist in Norman. Hey, Pat, talk real quickly about your job because he's got a cool job. He gets paid to go chasing tornadoes.
Yeah, thanks, Tim. So my name is Pat Hyland. I work at the National Weather Center. National Weather Center is a giant building on the University of Oklahoma campus, and it houses over 500 different meteorologists, researchers, climatologists. We have faculty, staff, students, technicians, you name it. It's the only National Weather Center anywhere in the world, so we've got a whole bunch of severe weather experts there. I'm actually so I work in affiliation with the National Severe Storms Lab, which is also part of NOAA. So I'm a research associate within that group. I am part of the SWAT team, and SWAT stands for Severe Weather Applications Technology Transfer Team. And so our job is to work on tools, algorithms, products, and techniques that can help forecasters provide better warnings to the public. So the stuff that we're testing, we eventually get that onto the workstations that Mr. Tim and others are using to give you guys more advanced warnings. So our job is to make sure that you guys have the most up-to-date information that you can. And yes, I do get paid to chase storms. I have keys to a $4 million mobile radar vehicle here at OU. And I was just talking with some friends yesterday because I had some possible tornadoes down in the Florida area. We were there doing lightning research years ago, and we're like, man, if only there were tornadoes coming through when we were doing our lightning stuff too. That would have been so cool. But yes, if you want a storm chase, OU is one of the best programs to come and do that too. And you can actually get paid as an undergraduate and graduate student to do all of that. It's really, really cool.
Very good. Now, like I mentioned, I'm in El Paso. Pat's in Norman, Oklahoma, which is central Oklahoma. You guys are there in kind of eastern Pennsylvania. And Mr. Trent Davis is a forecaster with the National Weather Service in Philadelphia. Don't tell anyone, it's in Mount Holly, New Jersey. But he's in the Philadelphia office, so he is our subject matter expert for your local weather. Trent, how are you doing?
Hey all, I'm doing pretty well. Yeah, so like Tim said, I'm not in Philadelphia, even though that's the parent city that we represent. We used to be in Philly, but in 1993 we moved out to just a suburb here in Mount Holly, New Jersey. So yeah, like Tim said, I forecast for your area. We have 34 counties that we service, 4 states, but yeah, Philly is the main area, the main show. So
very good. You know what, you mentioned the areas that you service. Let me go ahead and show my screen here, and I can show on a map what he's talking about. All right, let's see. Give me a thumbs up when you see the beautiful rainbow. All right, very good. Thank you. All right, so here's a map of the United States. And on this map, you see a lot of colors. Like Pat and Trent and I said, we all work for the National Weather Service in one way or another. And the National Weather Service is part of the US government. I know that when I introduce myself, hey, I'm a meteorologist with the National Weather Service, the first question out of people's mouth after that is, what TV station do you work for? And I have to explain to them, I don't work for any TV stations, I work for the US government. We're part of the Department of Commerce. And like I said, there's over 120 of these weather offices scattered all across the country. Each of the colors on this, oh wait, let me turn on my laser. Each of these colors on this map show you where a weather office is. Each weather office kind of focuses in on a little chunk of geography, and they become the subject matter weather experts for that chunk of geography. They issue the warnings, the advisories, they issue the weather forecasts. Like I mentioned, I'm here in the El Paso office, and we cover just a little bit of far west Texas and a big hunk of southern New Mexico. Like Mr. Pat mentioned, he's in the National Weather Center. He doesn't work directly with the weather office there in Norman, but he's in the same building. The National Weather Service Norman office, the weather office is in the same building that Pat's in, and they cover a big hunk of central and western Oklahoma and just a little bit of North Texas. And then like Trent mentioned, Trent, they actually cover 4 states. They cover a big hunk of New Jersey, a little bit of eastern Pennsylvania, Delaware, and a little hunk of Maryland. So those are the areas of responsibilities that they cover. If you have ever been at home at night and your cell phone or mom or dad's cell phones made that noise, it's the men and women working in Trent's office there in the Philadelphia office that are issuing the warnings to let you guys know when that bad weather is coming to town. Now, each of these offices issues those warnings, those advisories, but they also issue weather forecasts. And a weather forecast, that's just a guess or a prediction of what the weather is in the future. Sometimes that future is 5 minutes from now, if we're talking like tornadoes, tornado warnings. And sometimes that forecast or that estimate of what the weather is going to be could be 7 days from now. We issue all kinds of different weather forecasts. Like I said, it can be for aviation forecasts for people flying into Philadelphia or Newark, in the big planes, even some of the smaller airports. It could be for boaters on the Atlantic Ocean and some of the Delmarva area. Anybody with water concerns there. We issue a forecast for people who fight like the forest fires up in the mountains or in the grasslands and the lowlands. And we also issue forecasts for people like me and you, and we call that the public forecast. And, that includes things, is it going to be hot? Is it going to be cold? Is it going to be sunny or cloudy, rainy, snowy, dry, windy? All of that information so that you can decide, make that wise decision about, do I need to take an umbrella if I'm going out? Do I need to wear a jacket, or can I wear shorts? Because it's the mission of the National Weather Service to protect lives and property from the weather and to help people make wise weather decisions. And there's so many different ways that the weather can affect our lives. And again, each of these weather offices just kind of focuses in on their area of responsibility so that they can become the subject matter expert. Now, you guys, like I mentioned, you guys know that you're there in eastern Pennsylvania, so it's nice and green, it rains a lot. I like to show, especially when I'm talking to school kids all across the country, I like to show my office because it looks a little different than what you guys are used to. Like I mentioned, I'm in El Paso, Texas. We are essentially in a desert. We get less than 10 inches of rain a year. So as you can see, this is the outside of my office. The actual building itself is very similar to a lot of weather office buildings. And it's funny to see the same building when it's in Philadelphia or in Caribou, Maine, or in Boise, Idaho. It's the same building with big trees in one place, lots of grass in other places. But for us, we're a nice desert location. So we got a lot of rocks, we don't got a lot of grass, not a lot of trees. You can see in the background there, one of the cool tools that we use, which is radar. Let me kind of zoom in on it here. Weather radar is one of the tools that we use to help us interrogate the weather, get those very short-term weather forecasts out. Think of radar as like X-ray vision for thunderstorms. Let's just look inside the thunderstorms. Lets us tell which direction the rain is moving, how heavy it's raining, even gives us an estimate of how much it thinks it's rain. It can tell the difference between hail, snow, and rain inside that thunderstorm or that rain cloud. It can also give us an estimate of which direction the winds are blowing, and that's very important if you're looking for circulation beginning to develop in that thunderstorm, anything that would be a precursor of a tornado. The radar is one of the best tools that we have to get those short-term forecasts on developing thunderstorms. Now, this is the inside of my office. You can see we got a lot of monitors on the wall, got a lot of computer screens that we're all looking at. Each weather office monitors like local media because we have to respond pretty quickly if there's ever like a train derailment or a tanker car leak or natural gas leak or something like that, because we have to provide wind forecasts and weather forecasts to emergency responders, whatever the situation, if it's an oil spill, a big fire, or something like that. So we're monitoring local media all the time. We're also monitoring, like, we're trying to stay situationally aware as far as what the weather is going on. So we're watching all the webcams around the area. Some towns have webcams. You know, all the, you know, probably the Pennsylvania Department of Transportation has webcams all across Pennsylvania. So I know Trent's office will be watching those webcams. You know, for us, we're down in the lowlands, and I say lowlands, it's about 4,000 feet in elevation, but we have mountain communities up above 8,000 feet, and some of them have webcams, and it can be nice and sunny and warm where we are down in the valley, and snowing like the dickens up there in the mountains. So we like to keep an eye on to make sure that our weather forecast is going well. What's the actual weather that's going on? So we use all of this monitoring equipment to help us just stay on top of the forecast. We use the computers. Now, you guys at home may be used to a computer maybe with one screen or maybe with two screens, but all of our workstations are a three-headed beast, and we can display just about any weather information you can imagine on it. The center and the right screens have what we call our computer model data. We take a lot of current weather information, dump it into a big computer, it churns it along, chews it, then it spits out what it thinks the weather is going to be in the future. And we can pull up, and we call that a computer model. And we can pull up all that weather information to help us better see what the computer thinks what the weather forecast is going to be. Now, you think a computer would get the weather forecast right every time, but believe me, it doesn't. It takes us, our job is to interpret which computer model is doing the best job in forecasting the weather, which one's maybe not doing such a hot job. We can look at anywhere from half a dozen to 10 or a dozen different computer models when we're trying to put the forecast together. We can also display radar data, like I mentioned before, satellite data, which is on this screen here. Satellite's just a camera up in space that takes pictures. We can glue those pictures together, and it makes a nice kind of like a cloud movie. We can display surface observation data, you know, what's the temperature all across the area. We release weather balloons. A lot of weather offices release weather balloons twice a day, so we can get a snapshot of the atmosphere right above our heads all the way up to the top of the atmosphere. So we can display that data. So like I said, that's one of the challenges. Trent can tell you that as an operational forecaster, that's one of the challenges that you can have, is just this inundation of 10 different computer models, satellite data, radar data. It can almost be overwhelming, and it's our job to kind of filter that all through and figure out what is the forecast challenge of the day, what is the important thing that we need to focus on. Is it a day where the temperature's right around freezing and we're forecasting precipitation? That would be important. Or is it a day when the temperatures, you know, we can be, you know, have a little wider range on the temperature, but those wind speeds are something that's very critical. So we, you know, what is the weather challenge of the day? So now I'm going to kind of transition. I'm going to talk about the current weather conditions. And this was recorded, I guess, on April 24th at around 9 a.m. or 10 a.m., I guess, Eastern Daylight Time. You can see this is kind of a typical temperature map that you would see as we're into springtime. It's kind of still cold up here in the Northwest, where they're right around just a little above freezing, to where it's pretty darn hot down here in South Florida. I'm telling you, Miami, 85. Key West, 83. You guys there in Eastern Pennsylvania, they're on the chilly side, as far as I'm concerned. You guys are in the mid to upper 40s. You know, Pat's there sitting all nice and happy in the mid 60s, and I'm the winner temperature-wise, right at 71 degrees, and we're looking for a high right at 90 degrees today. So summer is well on its way for us. I can tell you this, but you can see we have a nice range of temperatures. You know, during the winter, you'll see some bitterly cold temperatures up here in North Dakota, South Dakota. During the summer, down here in the Southwest, you'll see some blazing hot temperatures. So, but this is a typical weather map where it's got some lows up in the north and pretty warm in the south for the, you know, a springtime kind of year. I mentioned the satellite up in space. This is the current satellite picture. A satellite is just looking down, takes pictures of the clouds. And usually the brightest, whitest clouds are usually thunderstorms. and we can we can put this in a loop and track this along, and you'll see where the brightest colors are as many times where those thunderstorms are, which direction they're moving. Are they getting brighter? Are they getting dimmer? So those are all kind of cues that we can use as far as being a forecaster. Now, if we look underneath these clouds, you can see we've got some showers and thunderstorms, and not surprising, you've got some showers where you guys are up there in the Pennsylvania, New Jersey area, but right where that brightest clouds were, there in the central part of the United States, they've got some showers and some thunderstorms. And right down there in Florida, where another band of bright clouds were, they've had some kind of what's left of, I was checking these at like 2 o'clock in the morning this morning, and it looked like a very impressive squall line that was moving through Florida, but it has now weakened somewhat as it continues to drop on to the south there in Florida, but it'll give them some beneficial rains down there. Taking a look at a weather map, the weather map is what we produced, kind of help people understand what the weather's doing. I know there's a lot of colors on here and there's a lot of lines on here, but real quickly, to summarize things, you see some L's and you see some H's. The L's stand for low pressure and the H's stand for high pressure. I tell people, the L's or the H's are the high pressure. They usually bring you happy weather, clear skies, nice conditions, where the L's, they stand for low pressure, but they also mean lousy weather. And you can see a couple of areas of low pressure. You've got this one here in the middle part of the Midwest, bringing, and this low pressure be helping to kick off this severe weather here in eastern Oklahoma, Arkansas, and North Texas. You got another area of low pressure here in the northeast part of the United States. That's why you got a chance of showers today. Now, if I jump ahead in time, this is the weather map for tomorrow. Oh, I forgot to mention, there's some lines on here. The blue lines are cold fronts, and the red lines are warm fronts. We don't have a lot of red lines on here, but you can see a cold front kind of coming out here, so it'll be a little colder behind that line. So the fronts are just the leading edge of whatever air is the name of the front. So if it's a cold front, there's cold air behind that front, and it's gonna replace the warm air out ahead of it. If it's a warm front, that warm air is behind that warm front, and it's replacing the cold air out in front of it. And you can always tell which direction the fronts are moving by which direction on the cold front the arrows are pointed, or the little semicircles. Here on the tail end, run right here where it's blue and red, that's a stationary front. That means it's not really moving in any direction. But you can see a pretty good cold front punching into the Gulf of Mexico. And like I said, another cold front coming into the northern part of the United States. And it looks like you guys got a good chance of rain there on Saturday evening as this storm system kind of wraps up into the northeast part of the United States. And if I jump ahead another 24 hours, so this will be into Sunday, you guys are still, you got this another area of low pressure coming up the coast. So continued chance of rain on Sunday, where you've got this area of high pressure. Even though there are some showers, it'll be generally quiet weather. I've got this cold front. I wish it was really that cold behind it, but I know for me it's not going to be. But you can see it kind of goes stationary. But this cooler air is kind of punching down into the Gulf of Mexico, and you can see more cool air kind of working into the northwest part of the United States. So that's basically, in a nutshell, our job, how we kind of do it with some of the tools and what some of the things that we produce to help you guys stay on top of the weather. But now, I know Pat and Trent and I are looking forward to answering some of the questions that you guys had submitted to us.
All right, take myself off mute.
Very good.
Yeah, one of my students, Daniel, asked a really good question, and he paired it with something he observed. How does atmospheric pressure change in and around thunderstorms? And there was a scenario in which helium balloons were put up in the summer, and as the storm was moving through, the balloons sunk to the ground.
Huh. I will let Pat, since he does that stuff, I'll let him talk about that. And I'm going to pull up a map or a picture of some people doing a balloon release near a thunderstorm.
Yeah, so we're launching balloons all the time into thunderstorms to try and figure out what's happening. More often than not, we're launching them into the updraft of thunderstorms. And updrafts are where air is being taken vertically. And so that's where we could put those balloons so they can traverse the entire portion of that thunderstorm. Because we want those balloons to go from the surface basically to the tops of those thunderstorms, which can get that sometimes they can overshoot actually into the stratosphere. So we're launching these balloons really high up into our atmosphere. But there's a lot of dynamics that go on inside thunderstorms. So what you have to know is the way that thunderstorms form in the first place is because the uneven heating of the earth by the sun leads to differences in pressure. So some places have more air molecules, so high pressure. Other areas have less air molecules, so it's lower pressure. And the Earth is always trying to achieve balance. Sometimes that balance is through thunderstorms, but it's trying to move air molecules from one place to another. So from places where there's lots of air molecules to where there's less. So the movement of those air molecules from high pressure to low pressure creates the wind. And underneath thunderstorms, we have usually converging winds. So because there's typically lower pressure there, those winds are converging and then they collide and move upward. And as those air molecules rise in the atmosphere, they cool and condense and they form liquid water, which are those clouds that you see. And if there's a lot of vertical movement, you can get some really big time thunderstorms that can have large damaging hail, lightning. Sometimes if you have a rotating updraft with those thunderstorms, they can create tornadoes. So there's a lot of different dynamics going on. The other thing is when we start getting a lot of that precipitation to fall out of the cloud, whether it's rain or hail, it's a lot colder. And so when that hits the ground and spreads out, it can create large gust fronts, but also it's creating colder temperatures at the surface. So you can actually get some sinking air within those cold pools. So typically where we'd see air moving up, we're not seeing it move up because it's kind of trapped in that cold pool, that colder pocket of air near the ground. And sometimes that can rush out well ahead of the thunderstorm. If it does, that means the thunderstorm's actually going to kind of dissipate because it's got no way to get that warm air in to keep it going. So there's lots of different things. So what you're seeing here, we do a lot of balloon launches. We actually launch weather balloons here in the US twice a day at coordinated times, about 92 locations, I believe, throughout the US that we do those balloon launches. And then if there's special scenarios where we are expecting, you know, thunderstorms, severe weather, sometimes hurricanes, we'll have special balloon launches that'll go off at different hours. We also have research teams that do specific types of balloon releases, not only into severe weather and hurricanes, but also into fire weather and also into winter weather as well. So these are what the balloons look like. The Weather Service balloons are about 5 feet in diameter and made out of latex. The research balloons that we have with the National Severe Storms Lab that we use are made out of polyethylene, and they're about 20 feet in diameter. They're massive, they're huge. But this is what they look like. So Mr. Tim's showing a picture here. So that balloon gets inflated by with some helium, and then attached to it there's a radio sound. It's a little package that has some weather sensors on it. So as the balloon's being carried up, it can measure the air temperature. It can get the pressure. It can get the wind speed, wind direction based on the drift of the balloon as it's being carried up. And the forecasters are using that to get a profile of the atmosphere so that they can forecast for severe weather and other things. So those are some of the tools. Again, you saw Mr. Tim showed radar. We also use balloons and satellite. We're trying to figure out everything we can about our atmosphere, and those are some of the things we use.
Thank you, Patrick. That's fantastic. Could I add to that a little bit? So storm chasers, obviously where they get their fame is their videos by getting close to the storms. But another question was, what is a typical storm chaser like Reed Timmer or somebody for the government? What do they have to do the day before, weeks before? How do they prep for this? And then during the actual chase, what are they trying to do to intercept and also keep everybody safe?
Again, I'll default to Pat on this.
Yeah, that is a pretty loaded question for sure. So I want to preface this by saying, at the University of Oklahoma, you'll see this with a lot of other universities as well, don't really condone storm chasing. Storm chasing is more of a hobby. So we really want to leave that activity to people that are doing the research on some of this stuff, because we don't want you guys driving out and looking at storms and trying to get pictures and video. We want you guys to stay safe. So getting into your safe place that you can identify at home or at school, and leave that kind of work to the professionals. But I will tell you that we have a group at the National Weather Center that's also part of NOAA and the National Weather Service. It's called the Storm Prediction Center. The Storm Prediction Center, if you guys ever get a severe thunderstorm or tornado watch for your area, it's actually coming from the National Weather Center, from the Storm Prediction Center. So their job is to look for the potential for severe weather all the way out to 8 days. So they're releasing outlooks for severe weather So if you've ever seen those risk categories on TV, it's a marginal, slight, enhanced, moderate, or high risk for severe weather. Your local broadcasters might use a scale of like 1 to 5 in terms of severity. They're taking that based off of the Storm Prediction Center outlooks for severe weather. And so they're trying to let you know the potential for hail, strong winds, and lightning, and hail, strong winds, and tornadoes within a given radius around a particular location. And so they are releasing that information. Sometimes it could be a week in advance. And usually if our numerical weather prediction models are showing that there looks like there's going to be the potential for severe weather several days out, and it's pretty consistent, that's when people will start mobilizing and getting ready. And that's emergency managers and others prepping their communities. That could be schools deciding whether they need to close or early release on those particular days. And that's also with our storm chase teams too. So we're getting that ready. We're trying to identify where we need to take our resources and go out and look for those things. Tim, I've got a picture up of one of our mobile radar vehicles. I'll do that after you look at the Storm Prediction Center thing here. So here's the outlook for today. So Mr. Tim was showing that surface map. So you could see there in southeastern Oklahoma and into Arkansas and portions basically around the Arklatex area there, there's an enhanced risk for severe weather. So now enhanced risk just means that, there could be either hail, wind, or tornadoes for that particular area. They're not expecting any sort of, massive outbreak or really like dangerous weather, but there could be some dangerous weather in that particular location. You can see the marginal risk and slight risks around those. And then what's really nice that the Storm Prediction Center has done recently is identify cities and how many people are going to be impacted by all these too. So now the atmosphere doesn't know that these lines were drawn by these folks at the Storm Prediction Center. So whenever you see these outlook areas and those hatched areas, know that that is the best, the best estimate that the forecasters at the Storm Prediction Center have about the potential for severe weather in that area. Storms could form outside of those, very well could form outside of those. So if you're anywhere near any of these outlook areas, you need to be paying attention to what's happening. So when we look at outlooks like this, our teams will then try to decide, we'll use a whole bunch of different data sets to figure out where we need to position ourselves to look at these storms. And we like to say that we're storm interceptors and not storm chasers, because we know where the storms are going to form and we wait there for them to go. We're not being chased by any sort of storms or trying to race after them. So, and some of our vehicles are, 13 tons, and we really can't move very fast. So when we have these vehicles out, we need to be able to set up at a place where if we need to move, that we can move. If our radar dish there on the back gets hit by hail, that's another $500,000 or so that we need to spend to replace that radar dish. So we don't want to be anywhere really close to it. We want to be back far enough so that we can look at everything and then move if we need to. That brown van that's in front of the truck that you see there, that's our scout vehicle. We call it the dog catcher. So that thing goes out ahead of our bigger trucks to find a good space for us to set up. So we don't want to be in a ditch on the side. We don't want any power poles or anything in the way of our radar. So we set up in a good location like this, and then we can start scanning. The truck in front of it is actually a mobile mesonet. So Mr. Tim showed a picture of the national conditions across the US. On the bottom, it said mesonet. We have a group with the Oklahoma Climate Survey and the National Weather Center that runs a network of surface observation stations in Oklahoma called the mesonet. And what we did was we put those mesonet stations on cars, and now we can take them out and do collect observations of what's happening at the surface using those. So these are all the kind of things. These projects are funded by lots of different resources, some from the federal government. We have like the National Science Foundation, sometimes get funding from NASA, sometimes Department of Defense. You don't get funding usually when you're a storm chaser. So usually if you try and go out and take pictures and videos, you might be able to sell some of those pictures and videos to media outlets and things like that, but you can't really make a career out of storm chasing. I know a lot of friends that try and make storm chasing a career. Like I said, it's a hobby. You can't really pay the bills with storm chasing. So if you want to be a meteorologist, take as many math and science classes as you can, go to a university that specializes in those meteorology programs, and then you can come and do all this cool stuff with us, and you get paid for it too.
Fantastic. Thanks, Patrick.
Yeah.
Trent, do you mind if I pose a question towards you? So my specialty
Sure, go ahead.
lies in snow forecasting, especially in and around the Philadelphia area. And I have like my favorites to use like just before predicting a snowstorm or what the accumulations are going to be. And I know you're new to the area. I don't know your background, or I think you went to Ohio State.
Mm-hmm.
But
Yep.
obviously we had a dud of a winter. But when it comes to nor'easters and winter storms, what's
Mm-hmm.
your favorite tool to use, and the challenges that you'd find with forecasting with that? And I'm curious to know your method.
Okay, yeah. So, like you said, we really didn't have much of a winter. I'm okay with that because a ton of work for our office. But yeah, like one storm would have been nice. But yeah, there really isn't like one go-to thing to look for. Like Tim was saying, we look at a lot of computer models. So we have an American model that we use sometimes. So some situations that's going to run better. In other circumstances, we might look more at the European forecast model. Sometimes that's better. Usually when those two start coming into agreement, that's when we have a better idea of what's going to happen. Like you said, it's the nor'easters, so it's that track of just 50 to 100 miles can make a lot of difference sometimes. We just really didn't have storm tracks that went right along the coast this year. They tended to move more from west to east, and they just went straight offshore. So we didn't get the cold air coming in. Yeah, here's a good example of that. So, and a lot of times in our area, due to what we call a baroclinic zone or temperatures, we have a big temperature contrast right off the coast with the Gulf Stream. And so these systems really get cranky in there right off of our coast there. And so if the everything comes together, they can move right up northeast along the coast. And if the cold air is wrapping up behind it, we can really get a lot of snow with them. A big challenge is also just looking at where that rain snow line is going to be. So Mr. Tim talked about getting temperatures accurately forecast. So that's a big problem for us sometimes as terrain. We actually do have a lot of terrain features in our area. We have the Poconos. They, out of systems like that, they can easily get 1 foot to 2 feet of snow. Sometimes Philly might stay warm enough they don't get any snow. As you know, warm air creeps up off the Delaware Bay and up the river. So it's subtle features, and we also have, a lot of people don't know this, we have something called the fall line that runs right along the river. So it's actually about a 500-foot jump from near sea level right through where the Delaware River goes up. And so it's that I-95 corridor that's really problematic. Sometimes we'll get a lot of snow right along there. The rain snow line falls just southeast of that sometimes. So yeah, we like to look for model agreements. There's a lot of ways to look at computer models. So if you're interested, you can go to our website. We show some of those on there. When I'm not at work, I have personal ones I like. I'm not sure how, maybe I can share my screen and search this here. And I'm not promoting this by any means, but I like to use this site a lot. I'm not sure if you guys can see my screen, but.
You went away. Which one do you want?
Yeah, I can't see it. Yeah. Were you looking at Pivotal Weather?
Or
I was
Pivotal?
going to say Pivotal, yeah.
Pivotal is a good one.
Okay, yeah.
Hold on.
Tropical Tidbits.
Tropical Tidbits is another good one.
Yeah.
I use
Pivotal
the College of DuPage site a lot.
Oh,
yeah, that's good too. The Pivotal Weather one was actually put together by a couple of our colleagues here.
Oh, really? Yeah, I love Pivotal Weather. That's a good one. I use that Tropical Tidbits and this College of DuPage site a lot. But you can just Google weather models, and then you can also, if you read our forecast discussion, which is on our website, if you're not sure what some of these terms mean, it automatically highlights them, so you can learn a little bit. Yeah, here's a good example of that. So I talked about the American and European models. So we're looking at the American one here. So GFS is a global forecast system, I believe. And so we're looking at that here. So you can see if it were more in the heart of winter here in this setup, we might get more snow with it. But of course, the winter pattern started a season too late. So this has been the case. It's been very interesting. The past couple of years, we've had this unseasonably cold pattern in April. We had some breakdown of what we call the polar vortex across the North Pole there. And so the cold air has kind of come down more late, not in winter, but in early spring. So it's just not cold enough right now. So we're not really getting that snow. We might get a little bit just to our north, but in our area, it's just this unsettled rainy pattern. But yeah, so it's really looking for the agreement amongst those two models. And we have a bunch of other models, like Tim said, we have up to like 10. So
Trent, that feeds into one of my students. They did ask a question on why it's so cold right now in April. For one of my students, Amir, he was curious about why we're having all the cold air now versus when it was back in March or February.
Yeah, good question. If you could go back to that pivotal weather map,
Sure.
Tim.
Coming up.
So that was a good question. So like I was touching on, we really had a good balance in the winter. So across the North Pole, the cold air tended to stay up there. This is kind of what the Climate Prediction Center was talking about in the winter, and it did pan out. So we look at things, again, we have a ton of acronyms, so I'm just going to throw this out there, something called the North Atlantic Oscillation. So that value was very positive. So it was like very cold air, concentric around the North Pole. It wasn't really breaking off into pieces. So the pattern didn't really have that cold air feeding in. So in our area, because we're right along the coast, you have to have advection of cold air to get a good snowfalls. Otherwise, our temperature is just naturally not going to want to be that cold. So in our case, we didn't really have that a lot this year. It's broken down a lot now, so that value is no longer at record values like it was. It actually broke some records. And so now we have the cold air coming down, but it's moderating a lot. And it's hard if you don't get a lot of snowfall building up to our northwest. The lakes never froze over. We don't have that cold air. The air that does advect down is not going to cool. So it's a big feedback cycle, and we didn't really have that this year. And there's a lot of other things that go into this. I'm not the biggest snow forecast guru here, but those are some things we looked at. We had a lot of rain, but the cold air didn't really come into place this year. But the pattern for the rest of the month, unfortunately, doesn't look much better than what it's been. As you saw from the next couple of days through the weekend, it looks kind of rainy. But yeah, we just have a pretty active weather pattern with systems every few days right now. So.
Yeah, Mike or Ed, do you have any questions that your kids posed?
Yeah, I have a couple. I'm going to combine it into one. Ashlyn and Leo were asking about how it forms. And then Max was also asking, in your opinion, what's the worst type of weather, tornadoes, hurricanes, or something else? So I think those questions are all related. So, and then I had a question after.
It all depends, because when you're looking at weather and what's the most strongest or powerfulest or deadliest, again, that's why there's so many different weather offices. We have so many varying different kinds of weather. The number one killer for people out here, for me, is dust storms. And that's just not something people think about. But every year we kill 2, 3, 4, 5 people with driving into a dust storm. And it's like driving into fog or worse. You just can't see. So each parts of the country have kind of different uniqueness. We get flash flooding, we get dust storms, we get a lot of lightning. Other parts of the country get real heavy snow. Southeast is looking at hurricanes or severe weather. So, it all depends on how you want to rate it. The big sexy things, the tornadoes and the hurricanes, get a lot of press, but when you start looking at the numbers, the number one killer of people weather-wise in the United States is the very unsexy heat. Heat kills more people each year than any other weather. And the reason for that is that we don't notice it is just one person here, it's one person there. It's not like a very concentrated where everyone's watching when there's a tornado outbreak or when there's a hurricane. Flash flooding picks off one people at a time. Lightning, those are things that actually kill more people than a lot of people realize, but they don't get as much play because of just the way, I guess, people's nature. They're drawn to tornadoes, drawn to hurricanes and things like that. So there's lots of different weather threats, and that's what makes it a challenge for the Weather Service, is to be up on all these different weather threats. We're all kind of, like I said, the subject matter expert in our areas, and just staying on top of things. I can tell you, I'm not, for the Norman office, they're probably pretty used to cranking out tornado warnings. We're in El Paso. We maybe issue one a year. So it's a challenge for me to make sure that I know how to do that and remember to look for the signatures. I'm more looking for heavy rain, flash flooding kind of signatures, but every now and then all the weather ingredients come together just right. And I got to be on my toes to make sure that if the tornado does form, I'm ready to issue that warning as well. So those are all some of the unique challenges we as forecasters face. I don't know, Pat and Trent can kind of chime in on what they think the most significant kinds of weather are, but for me, it kind of just depends on where you are in the country.
Yeah, that's definitely for sure. But obviously, everybody always talks about tornadoes and hurricanes being like the big ones for sure. Now, where I am, tornadoes are the thing, like everything. Last year in Oklahoma, we had 147 tornadoes in our state in a calendar year, and that was the most that we've had since 1999. And in May of 1999, we actually had one of the largest outbreaks in our state. We had over 60 tornadoes in a 24-hour time frame, and we had the fastest tornado that's ever been measured on planet Earth, and that was 318 miles per hour. It was an EF5 tornado that basically went, I probably could see it from my house currently if it was ongoing right now. So we get a lot of those here in Oklahoma a lot, and it's because we're just set up in just the right part of the country for those ingredients to come together. Now, the way that tornadoes and hurricanes form are completely different.
Mm-hmm.
So some things that work for tornadoes don't work for hurricanes. So one of the ingredients that we need for tornadoes is a lot of shear. Shear is the change of wind speed and wind direction with height. So say winds are going like this at the surface, and then up higher, they're going like this. So obviously, with different wind speeds and wind directions, those heights, things are going to start spinning. So that's what gets a lot of our tornadoes going here if we have a lot of shear. Now, for hurricanes, if you have a lot of shear out over the water where that hurricane's trying to form, it's going to rip everything apart. So shear is really bad for a hurricane. It's really good for getting a tornado to go. And the heat source for, basically the energy source for hurricanes is that warm ocean water. So as they're camping out over the warm ocean water, moving really slowly, that's where they get their energy source from. And when they finally make landfall, that's when you see them start to break apart because they don't have that energy source anymore. The energy sources for tornadoes is basically when you get that shear, but also, moisture does play a part in that too. You definitely want to have moisture, and you want the atmosphere to be unstable. And when we have an atmosphere that's unstable, air can just freely rise and nothing is stopping it. It's basically like a hot air balloon, like that guy's cranking that chain and it's just going straight up into the atmosphere. That's exactly what happens when we have big time severe weather days here. So Mr. Tim brought up a very good graphic here. Most people think, tornadoes and hurricanes, you hear about them on the news, you're like, well, those have to be, the biggest weather disasters that we have here in the US. And like Mr. Tim was talking about, heat and flooding, the two things that people take the most for granted are what actually ends up killing the most people here in the US. And so that's why, people think, oh, it's just, the sun, heat, oh, it's just water. Moving water has a lot of power to it. It only takes 6 inches of moving water to sweep you off your feet. It only takes a foot of water to move a small car, about 2 feet of water to get an SUV or a larger car. So really, it does not take a lot. And that flood water can wash away roadways. So people try and drive through those areas. They end up getting swept up and taken away. So turn around, don't drown. Those are really important things to remember if you happen to encounter a flooded roadway. But yeah, don't take for granted any sort of the weather hazards that we have here in the country. It's not just tornadoes and hurricanes, it's a lot of other stuff too.
And then the other question was about the hail, and they were asking how hail forms. We hadn't gotten that in our curriculum yet, so they were just wondering that as well.
Sure. Yeah, so hail, so in thunderstorms, as I was mentioning earlier, we have things called updrafts, so that air rushing up really quickly. We also have downdrafts too, I mentioned that as well. So all that rain cooled air, and there could be some like frozen stuff in there too, falling to the surface and spreading out. So with air moving up and down, when you have a water particle that's sitting there, it could be picked up by that updraft. It goes to a higher portion of that cloud where it's a lot colder. So it starts to freeze. And then the downdraft of that storm or other dynamics of the storm might take it down close to the surface where it's a little bit warmer, and it starts to melt. And it might be picked up again by that updraft and go back up and refreeze. So it keeps this process going until the effects of gravity take that out of the cloud, or it just falls naturally. So you can kind of think of it as almost like a water cycle, but it's happening like inside the cloud there. So, ooh, updrafts. Are these like, this must be a European.
Oh, European. I didn't even know.
So yeah, so this is basically what's happening. So near the bottom of the cloud, you have a lot of water droplets. Kind of in the middle of the cloud, there's a little transition zone. We could have some mixed particles, so there could be some water and ice particles that are interacting there. Higher up in the cloud is when you get to your snowflakes, your dendrites, your ice crystals, your columns. So as this air, all these dynamics are happening within the thunderstorm, all of these things are moving up and down. They're refreezing, they're melting, they're refreezing. And then eventually the hail does fall to the ground too. Now the largest hail that we've measured was 8 inches in diameter. That's basically like a size 3 soccer ball falling from the sky. And Mr. Tim, correct me if I'm wrong, I think that's in South Dakota, was that one?
Vivian, South Dakota.
Vivian, South Dakota. So 8 inches in diameter. So that's massive. Now, you hear that and you're like, oh my gosh, yeah, of course, that's huge. But there's not a whole bunch of size 3 soccer balls falling in that area. There's probably a lot of smaller hail pieces falling with those really big ones too. So yeah, that's basically what it looks like. And what's really cool about how the way that hail forms is sometimes you'll get this kind of craggy stuff forming too. Other times it'll be a lot smoother and whiter, and it just has to do with the water content, how much moisture's in there, the different motions in the air that's going on. What's really cool is using our Doppler weather radars, we can actually see how the hail tumbles in the air based on looking at some of the signatures from the radar. So we can kind of figure out what types of hail we're gonna see watching that tumbling feature that they have.
Thank you very much. And then I just have one more question for myself, I guess. I want to cheat a little bit. With all the quarantine and the lockdown, so there's been a lot less CO2 released in the atmosphere. And I was wondering when we're actually going to see the result of that in climate. So is it going to be months? Is it going to be years? So I guess that's really hard to figure out, but that's what I was wondering about. So,
You know,
if anybody
I've already seen plenty of pictures of some short-term results. If places like Mumbai in India, they showed a picture of just this pollution-filled picture, and then just recently the exact same picture, and it's like crystal clear. So we are starting to see, you know, without people running around driving willy-nilly, all of this stuff, industrial work slowing down. We are seeing, at least from a pollution point of view, some improvements in the atmosphere. As far as how much carbon dioxide we're dumping in there and it going down, I think we would have to do this for quite a while for it to start to see those numbers start to trend down. The official place that they measure the carbon dioxide rating for the world is out in, I believe it's Hilo, Hawaii. And you can just see it's just going up like this. It will be interesting, you bring up a good point. It will be interesting to see if it's going up as steep or if it kind of levels off or even goes down. But my guess is if I understand how things are going to work, here pretty soon we're going to start to slowly ramp things back up. I don't think this break that we've taken from all of this industrial activity is going to be enough, other than maybe a temporary blip where we don't go up as fast. It's going to take a more concerted effort from us as a society to kind of curb our CO2 emissions, whether it comes from your family car or more from the industrial kind of machinery that we have in the country and around the world, to really start to see trends that would make a difference. And even then, it will take tens and tens of years to start to see the results of those downward trends.
Thank you very much.
Appreciate it. That's a good point. Just to follow up on that, like you were saying, Tim, the lifetime of CO2 is on the order of years, so it's going to take a long time. But since we're not pumping as much in, that rate of increase is probably going to drop a little bit if we look at it over the next few months. But also, like you were saying, the NO2 levels and ground level ozone has gone down a lot, especially in like the New York metro. I don't have any off the top of my head the numbers, but I've looked at some people posting some maps about that, and you've seen a lot of improvement there, better air quality in the Philly and New York metros. So for those type of things that have shorter lifetimes, there's definitely been a good improvement here.
Just real quickly, here's a picture of, and it was Mauna Loa out there in Hawaii. As soon as it comes up, this is just the upward trend from the 60s to now of how the concentration of CO2 in the atmosphere, and you can even see within the years it goes up and down. So it's one of these things that it's going to be difficult if we ramp back up here in the summer and into the fall and get fully back up to going, or at least some modicum of that. It will be very difficult, because there's just like the temperature from day to day kind of goes up and down, but you can find a trend when you look at it over a long term. This kind of goes up and down from year to year. So it will be difficult if this stays short, like it seems like it will be, for us to even notice more than a blip on this chart kind of thing.
So you guys have answered a lot of the questions that my students have had so far. One that I would like to ask would be a two-part question. So somebody asked, how much better is forecasting now compared to 20 or 30 years ago? And then the second part of that question, it would be, how long does it typically take to make a forecast?
Hey, Trent, why don't you go ahead and start off on that, since you're an operational day-to-day forecaster, and then Pat, maybe you can fill in on your role is trying to help us forecast better.
Yeah, sure. To speak as of the 20 or 30 years ago, I wasn't alive that time.
Actually, I can address that here in a minute. So you keep going.
So I'll address the latter part of that question. I know it's gotten a lot better from word on the street, but otherwise, yeah, it depends on quiet days where there's big bubble, no trouble, high pressure. We might pump the forecast out in a matter of a couple hours. We usually break it up into, we have something called the long-term forecaster and the short-term, near-term forecaster. So that short-term person is going to go out for usually about 36 hours. So they'll do the next day and a half. And then the long-term person will do from that day and a half all the way out through day 7, like Mr. Tim talked about. So on our website, if you click on anywhere, like where your location is, that will show you the forecast for the next 7 days. So it depends on who's doing each part of those. Sometimes we might even break it up further. We might have somebody just doing the whole forecast, all the grids, and someone else is doing forecasts for the airports. But given day to day, on a normal day, we have 2 or 3 people in the office. We have a lot of big airports, so it takes a lot of extra manpower sometimes to do those, especially like today where the ceilings, the clouds heights are going all over the place. So that can be a little confusing. If there's stuff on radar, someone else has to be taken off to do that. Sometimes we hardly do any forecasting if there's a lot going on currently. Especially now, because we can't have a lot of forecasters in our office at one time, that becomes challenging. So we have other people doing social media. I tend to do that a lot, getting reports, pumping out forecasts, information on there. But yeah, generally, if it's a quiet or normal day, we can get it done within 2 to 3 hours there. Depends on how much we want to write too, because we write out everything we do in our forecasts. We try to be pretty detailed about that. So if you want to read into why the forecast is different from somebody else or something, you can go to our website and read into that. But yeah, Mr. Tim probably has some more to add on the evolution of the process.
Yeah, so when you go to the Philadelphia Weather Office, what you want to look for is a thing called the Area Forecast Discussion. That's the specific, or AFD. If you see that, you can actually pull up and see whoever the forecaster was. This is their forecast philosophy and why they're doing what they were doing. Let me show you, talking about how things have improved over the years. This is specifically talking about winter storm temperatures. And basically, you have to understand that the further out in time you go, I'm sorry, I clicked on the wrong button there. The further out in time you go, the harder it is to forecast. The more likely is it's going to be off. You know, back 30 years ago, maybe closer to 40 years now, you know, on a day one forecast, we were off temperature-wise by over 3 degrees. But this day now, you got to go out to day 3 is when we tend to make that average of a 3.5 degree forecast. So you can see how temperature trends have definitely improved, especially in this range of the 5-day forecast. Once you get out about 5 days, that can be real challenging of a forecast. But you can see what was almost a 7-degree error back in 1975 is down below even 5 degrees now. And again, when you're talking about winter storms in particular, as you guys saw this winter, that can make all the difference in the world as far as, you know, whether you get rain or snow. So there definitely have been improvements. And I'm gonna let Pat talk real quickly about some of the things that his group is working on.
Yeah, so we have here at the National Weather Center, we have a couple of different experiments that we run pretty much yearly now. It happens in the hazardous weather test bed, and we have something called the experimental forecast program and the experimental warning program. So we have people, we have researchers within the Weather Center that are inviting in forecasters. I'm going to show a little video here of kind of one of the things we're working on the warning side, at least. So right now, when Trent or Mr. Tim are about to issue a warning, they have a little polygon, like a box. Now, everybody that's inside that box gets the warning, but everybody outside doesn't really get that warning whatsoever. So one thing that we're going towards is kind of identifying those threats and then giving people updated information as those threats move in motion. So the way that currently works right now is, you see how it works. You have to issue a new box. You have to draw a new box as that storm moves, and especially if it's going into one forecast area compared to another. With the new way we're going to do it, think about those hurricane tracks you've seen on TV, those plumes that we draw. What's nice is we can actually persist those plumes and have them move with the storm also. So that way, the people that are sitting at that 30-minute mark out there are going to continually be within that warning area, and it's going to move and evolve. The forecaster will actually be able to change and update these plumes every mile every 2 minutes. So it's going to be much more updated information. So you can see that's the new user interface that we're coming up with, that we're working with broadcast meteorologists, emergency managers, and other forecasters to test this out and to see if it would be useful within this operations. So here's a really good scenario. So you've got the two memojis there. So in the box, so that's currently how the Weather Service does it. So 30 minutes out, she has an idea of what's coming, but Hector back there has no idea that that storm is coming until it's issued there. So instead of a 30-minute window, he only has a 12-minute window. With our new threats in motion, she'll get that 30-minute notice there, he'll get that 30-minute notice there, and they're going to be continually updating within that time frame too. So that's one of the things that we're working on and testing out with forecasters. So we're really excited about that. So in the future, when some of your students might be in college, you might start seeing some of these new warnings, but it's going to take a whole new way of thinking about things. And Mr. Tim and Trent are going to have to change how they've been doing stuff for a long time. So we know sometimes people don't like change. So change is coming, but we're working on some really cool stuff now to improve forecasts and warnings.
Awesome, thank you. The other question that hasn't been answered yet that I got from a student was, why and how are hurricane or cyclone names chosen? And are there some names that are never going to be used?
Trent?
Yeah, so we have I forget how many. We have a list that the National
I'm coming
Hurricane
up with
Center
it.
cycles through. Yeah, so Tim's bringing that up. So we have lists that they cycle through, and then if tends to be the more impactful storms, such as Sandy, will retire those names, so they won't be used anymore, because we don't want to say like which Sandy 1, 2, or 3 was it they were talking about. So it's one of the ones that hasn't been retired. I think like Alex, that one keeps coming around. It hasn't really ever been that bad of a storm, so they keep getting used. Yeah, so there we go. So we got 6. I thought it was 6 years. So we cycle through these so you can see what coming up. So this year Arthur will be the first one. I think there's like a voting session if they retire the name, or I get there's a criteria if they retire it. So but generally the name will just keep cycling through every 6 years.
Yeah, it has to be. Yeah. Oh, go ahead, Tim.
Well,
So the way that these names are, so the World Meteorological Organization has a giant book of names, and it goes alphabetically, male and female names. Way back in the day, it used to be based on where the location that particular hurricane or typhoon hit, and sometimes they use holiday names also. And then it went to using all male names, and then went to alternating male and female names. And if that hurricane or typhoon makes it to major category, so that's category 3 and higher, and does significant damage, that's when they do that retirement vote that they were talking about. So you can see that list of 2016 there. You could see a couple of names that we'll never have ever again. So you will never have another Hurricane Matthew ever again, because that was almost category 5, basically category 5 when it hit Florida. And then into 2017, you're not going to have Harvey. You won't have, I believe, Maria is going to be included, and Irma, Maria. So those names will never be used again, because they were major hurricanes that did significant damage here in the U.S. So they'll just replace those names with other ones in the list and keep going from there. So you might see your name here in some of the upcoming hurricane names list.
Still no Hurricane Tim.
Thanks.
Or Trent.
Or Trent, yeah.
There was a Patty. That's close to Pat.
I know, like I was gonna say, like there's never been a Patrick. It's always been Patty or Pat. Or something.
Now, my parents' names are always right after each other. There's Lee and Leslie. So they're always 1 year after each other.
There you go.
Anyone else have? I have kind of a goofy question.
We like goofy.
But I love goofy questions.
Wait, hold on.
Here we go.
Did my auto update just come on?
You're still good.
Okay, I lost you guys. Trent, you said one of my least favorite weather terms. I can't stand. I can't stand when they say I-95 corridor. I don't know why. That just drives me nuts. I want them to come up with a new term, and I still can't find one. But the question is,
it's perfect because it divides our area right in half.
What's the river? There you go.
What's that?
Just use the river, the Delaware River.
Delaware River. There you go.
But then it cuts off North Jersey, and the I-95 follows the fall line, so that's why we like to use it.
I say,
problem is you have to say northwest and southeast of it.
Everybody's favorite weather term and least favorite weather term.
Let's see. I need to think about this.
Traver, we talked about it. I'll start. My favorite is mesoscale banding, and then my least favorite is I-95 corridor. But Mike, you had
that's not a weather term, so yeah.
So
I know from yesterday, Herm. I like bombogenesis.
Okay.
Bombogenesis. That's a good one. I know my favorite weather term. Yeah, my favorite weather term is graupel. It just sounds cool. It's little baby hail. It's when you see little mushy hail that falls out of the cloud. It's not very significant or anything. I just like saying graupel.
Let's see.
I was gonna say, go ahead, Trent.
Okay, sorry. It's very corny, but you asked for it. So my favorite term is wet microburst. It sounds funny to me. And least favorite is probably tornado on the ground. When people say that,
That's true.
it's redundant. It's like
It's already
obviously a
there.
ton of tornado.
It's already there.
Tornado on the ground.
Yeah. So my favorite weather term is probably tornado genesis, because it just sounds like super cool. And that's basically when the tornadoes just start forming, and like my mind up goes to like Phil Collins and Genesis also. So like playing some dramatic music in the background. I think my least favorite term, I think any term that gets picked up by the media and blown out of proportion is one that I don't like. So polar vortex is a normal thing that happens, but whenever they hear polar vortex, they think that it's this like brand new phenomenon. Bombogenesis was also very controversial too, so I heard that one mentioned. So there's some people in the weather community that are like, I hate bombogenesis.
Sorry.
Yeah, like they could call it. No, that's fine. I like it too. What's really funny is, so we were talking about like the I-95 corridor. There's so many people that it's hard for them to tell, where exactly they are in relation to weather sometimes. And James Spann did this study down in Alabama. There's a lot of people that cannot identify themselves on a map. They don't know where they live. So if you show a county map of your area, there's some people that have no idea where they are in that county. So if you have a storm coming in, they're like, oh, it's in this county. People are like, well, is that the northern part of the county? Is that the southern part of the county? So I think one of the best things for you to do is to know where you are geographically on that map, where you're located. That's really important, so that when all these products are coming out from your local office, and when the people on TV are talking about it, they know exactly where you are. So geography is important. Don't forget your geography.
Yeah, our kids struggle with that one. So, yep.
And we
I
actually
found some
just
others
added
that.
in our
Go ahead, Trent.
warnings too. We actually added in the mile markers of all the interstates and like the Atlantic City Expressway, Pennsylvania Turnpike. So that's all in our warnings now. So you'll be able to hear like along this between these exits. So if you have a general sense of where those happen, you'll know where the storm is.
So I found a list of some kind of cool names that I hadn't even thought of and remember, but I also like thunder snow. That's when you get a thunderstorm with a lot of snow coming down. Then another one, a fire-nado. So you get when you get these wildfires, they actually start to create their own environment, and you get a dust devil mixed into there, and all of a sudden, dust devil and fire. Guess what? You got a fire tornado. And then one of my favorites, and I forgot about this one. You think I'd remember this? Is haboob. And that is a big giant dust cloud. And I get those all the time here in the desert Southwest. And it actually leads to a lot of our accidents and car crashes. Imagine a big dust cloud that is thousands of feet tall, and it just bowls into your city where you're going from bright sunshiny day to pitch black darkness. So haboob is a good Arabic word.
Jeremy, do you have one?
My favorite is the mesoscale convective complex, the NCC. I just love that combination. And probably
MCC,
my least favorite would be the bombogenesis. I can't stand when they use that term.
I should have never said it.
Or when the storm really bombs out. I don't know. It just sounds easy to me.
Dramatic. It's too dramatic.
Sorry. Yeah, I know. So.
Any favorite meteorologists, like old TV guys, or you guys know Lloyd Lindsay Young? Do you remember him? New York meteorologist.
I don't remember him.
Yeah, I'm not sure. I grew up in the Cleveland area, so at the very beginning, we had Al Roker for just a little bit of time. But Al is not a meteorologist, so he got his degree in communications. So he's a weather person that's on TV. So not everybody that's on TV is a meteorologist, but there are a lot more on TV nowadays that are meteorologists than what there used to be in the past. And then I think the big one, so here in Oklahoma, we had a very famous broadcast meteorologist that was on TV for a number of years and was the first to display a tornado warning from the Weather Service on TV, and then was really impactful in the May 3rd, 1999 tornado outbreak here in Oklahoma. That's Gary England. If you say Gary England to anybody in Oklahoma, like their eyes light up and they've got a story about it. So he was kind of seen as like the weather god in Oklahoma, and there's a lot of people outside of Oklahoma that know about him too. So he is pretty famous. So those are the ones. But I have a lot of colleagues on TV now that do really good jobs in all sorts of different markets. So it's cool being connected with them. That's what's cool about meteorology, is it's a small field, so we all kind of know each other.
You know, Pat mentioned James Spann down in Birmingham. He does a lot of, well, he's very opinionated, and his opinion sways a lot of people, and he's very entertaining. So he'll pick up on a subject like outdoor sirening or versus homes versus mobile home safety, and he has a weather podcast, and they a group of meteorologists sit around and just discuss the different weather issues, current weather situations. So, but James is a very well-known television meteorologist as well.
And he knows Alabama so well that when he zooms into an area, he can start naming off restaurants and convenience stores and bait shops and everything. Like, he's got it down to he knows basically every street in Alabama, which is pretty crazy.
And again, that's important. That's important because as meteorologists, we're storytellers, and James is great at, and we in the Weather Service, like Trent mentioned, we try to relate it to things that people talk about. So whether you like I-95 corridor or not, everybody knows where that is, and everybody can relate to that. Putting mile markers on there, you know, you may not know where you are on a map, but you know that you get off at exit 23 on the I-95 corridor. So if they say there's a tornado near, you know, mile marker 25, you're going to go, I think that's pretty close to me, kind of things like that. If you name different neighborhoods and things like that, different street intersections, that helps people who maybe are geography challenged to put that in perspective of how close is the threat to them. And again, it's our job to get people to take action. And if they don't think they're under threat, they go, that's on the other side of town, that's not coming my way. They won't take action. And it's our job to make sure that when the threat is real for them, that they do take that kind of action.
No, that's good. And I know we're a little over an hour in. Do you have any parting thoughts that you'd like seventh graders to think about as they go forward in their education? And I'm sure some of them might want to know, what do you have to do to become a television meteorologist? Or, you know, what do I need to start looking for when it comes to courses, universities, and things like that? Because as you know, they're so into social media and video that the idea of being on TV's got to be pretty thrilling for them, if it's possible.
Sure. You know, to get a degree in meteorology, people, they think about things it's like 10 years in college or something like that. And it's actually just it's like a regular bachelor's degree. 4 years to get a bachelor's degree in atmospheric science. If you want to continue on with your education, another 2 years for your master's degree, and beyond that, you can get even a doctorate. I tell people, especially kids in junior high, middle school, as you wrap up junior high or middle school and head into high school, if you want to be a scientist, whether it's a botanist, a chemist, geologist, volcanologist, any of those meteorologist, take as many science and math classes as you can when you get into high school, so that when you get to college, because I will tell you, meteorology, it involves a lot of math and science. Calculus 1, Calculus 2, Calculus 3, differential equations, physics 1 and 2. Those are not easy classes, but guess what? If I can get through them, you can get through them. It just takes effort, and it takes you working through them. But having a good foundation will really benefit you when you get to college. I wanted to be a television journalist. So in high school, I took intermediate algebra, and I said, that's all I need. And then about halfway through my college career, I decided to be a meteorologist. And they said, come back and see us when you finished Calc 1, 2, and 3. And I was like, So I had to teach myself trigonometry and calculus, and that was challenging. But like I said, if I can do it, you can do it. One other thing I would recommend, even if you don't want to be a scientist, no matter what job you're aiming for, take as many computer classes as you can. There is no job anymore that doesn't deal with computers. And we all have these now. These are, this is not a phone. This is a computer that happens to make phone calls. There is no job now, whether you're flipping burgers at McDonald's or landing a 747 airplane. They all involve computers. You can ask your teachers. They're having to input grades and lesson plans into computers. The people in the Army are doing tactical things with computers and flying unmanned vehicles with computers. So there is no job these days that doesn't mess with computers. So I encourage everybody, take as many computer classes as you can. That's my 2 cents worth, Pat.
Yeah, no, that's definitely, I want to be a meteorologist ever since I was in 2nd grade. So unlike Tim, I was like, I'm ready to go, let's do this. So yeah, I did take as many math and science classes as I possibly could. As you're starting to, when you're getting into high school, things like that, start looking around for universities that offer opportunities for degrees in meteorology. Some might be really close to your house, some might be a little bit further away. There's lots of really great programs out there, and it will be a rigorous degree. But I'll tell you, the USA Today did a study last year, and atmospheric scientists, meteorologists, has the least amount of unemployment in the United States. So, and the reason for that is because weather is not going anywhere. Weather is going to be here forever and ever, and we're going to need meteorologists to be able to diagnose the atmosphere, to tell people what's going on. So our jobs are never going to go away. And you know what? We're traveling to other planets right now too. There's weather on those planets, and we have people that are already studying the weather on other planets in addition to our own. So there's a lot of unending opportunities in our field, just because there's always new questions with every severe weather outbreak, with every hurricane, with every flooding event, winter weather event. There's new things that pop up that we've got to figure out and answer those questions. So there's just an unending amount of opportunities available in our field. It's a really exciting field. Like I said, it's really small, so we all know each other. And so we all help each other out with a variety of different things. And we've gone to all these different universities that Mr. Tim has up here on the screen. And some of these, so certain areas of the country will specialize in certain things based on where they are. So some of the Central Plains and Southern Plains universities will have a lot of emphasis on severe weather. Some of the ones in the Northeast may have more of winter weather and synoptic meteorology or large scale meteorology. There's also some pockets of broadcast up there as well, like at Penn State University. Some of the ones now in Florida will focus on tropical meteorology and hurricanes and things like that. So you can see there's opportunities all over the place.
Yeah, I agree. I also wanted to plug in if you are in social media, like following people on Twitter is a good thing. I learned a lot from that when I was in high school, and Twitter was very new then, but I follow a lot of people. I watched them on television. I learned all I could. I went to job shadow them. That's how I really decided I wanted to work somewhere in meteorology, and then I thought I honed it in onto National Weather Service. So if you have those opportunities, we always take volunteers or tours once this stuff is done. So if you want to come in and tour, feel free to do that.
I just wanted to jump in real quick too. I always mention it to the kids. We use, I know Dr. Herm and Mr. Steinhardt and we did the data stream courses through the AMS. And all of us have been to Mount Holly through those courses. That's where we would always end up at the end of the year. And they have a nice student, you can sign up as a student subscription to the American Meteorological Society. It's pretty cheap, and if kids are really into it, that's something that they can check out and be a part of an organization like that. The data stream classes were outstanding that we did. Nothing.
Comet also has, if you do meteorology Comet lessons, they have a lot of lessons online that you can access.
It's so much
Comet
their data stream website I still use today. So I mean, them all the time.
Yeah, get involved early. Like there's opportunities for high school students with the American Meteorological Society. I joined AMS when I was a junior in high school. So yeah, so get on that stuff early, and you never know, there might be opportunities or maybe even scholarships ahead of time before you even get to college to take advantage of all that stuff and job shadow and tour, like was mentioned here.
I know. I was taking those courses when I had Michael Traver sitting right there. So he's a former student of mine. So now we get to teach together.
And you know, there's so many different areas even within meteorology. Pat said it's a small group, and it is, but within meteorology, there's atmospheric chemistry. You know, there's aerosols in the atmosphere. They're doing research on lightning and on tornadoes and specific weather elements. You have your frontline kind of weather forecasters like Trent and myself. So there's lots of opportunities. You know, since weather affects so many different people in so many different ways, there's private industry meteorologists. You know, FedEx has some cool meteorology center because, you know, you don't want your packages delayed because of thunderstorms or anything, so they have to figure out how to fly planes around thunderstorms and things like that. Walgreens and CVS, they have a big communication center, and they have meteorologists there because one of their people came and talked at a conference, and they said, almost every day during the summer, a Walgreens is somewhere in the United States is under a severe thunderstorm watch or tornado watch. It's just because they have such a big footprint across the United States. All your professional athletes that are professional leagues that take part outside usually hire meteorology or somebody to help them, because, you know, you don't want Tiger Woods being struck by lightning, or, you know, one of your baseball superstars, you know, getting caught in a big heavy rain or things like that. You know, you want to make sure your doors are closed on your stadiums before the rain gets there, things like that. So there are lots and lots of opportunities. I think Pat and Trent and I would all say there's lots of great opportunities within the government as far as being a meteorologist, but there's lots of private. TV is a way to go. And then, you know, there's just lots of opportunities in the United States to be meteorologists because we have such wild and wacky weather.
Tim, I'll give you another crazy one. I have a friend who's a fashion designer, and she tells design companies when to release lines of clothing based on what the weather's going to be like over the next several months. So if it looks like it's going to be warmer earlier, she'll tell groups like H&M to put out their spring lines a lot earlier than just waiting until spring, their spring sales and things like that. So yeah, you can be a fashion designer in a meeting.
Yeah, I'm really glad you guys said that, because that was something I forgot to even think about. But yeah, so being a meteorologist is, I mean, what % are on television? Is it less than 2?
It's about 10%.
Okay.
10% of all meteorologists are on TV. So that means the other 90% of us, and you've got 3 of them right here, are doing something else. So yeah, it's, you know, and weather impacts everything. So there's really an opportunity out there and everything. And if you have a meteorology degree and an internet connection, you could start your own weather company. You could really do it on your own.
And it's a very helpful scientist community. I mean, just like you guys, Trent, I only knew you from Twitter. You got back to me right away. Tim, you joined in right away. Patrick, I didn't even know you were coming, but you can always count on a meteorologist, I feel, to help you out, like in a jiffy. So if it's education or just assisting or picking up the phone and talking about a storm and, you know, and geeking out over something, it's a very friendly crew. So it's like you're automatically a good guy if you're a weather person.
It's the nature of the science, because weather can be such a threat to people. We get in it to help people stay safe from the weather. We get in it to help people make wise decisions about the weather. So many times it naturally attracts people who want to be helpful and to be servants and things like that. So I'm not surprised at all. There's so many men and women in the Weather Service who I've read stories about people, you know, walking through snow drifts to get to work, or, you know, working 24, 36-hour shifts during hurricane outbreaks and things like that. It's just a service to the community that we can provide, and we're just glad to do it.
Before we wrap it up, at least for the recording, before we say our goodbyes, does anyone have any other questions or anything else to add? We literally, I think, covered our entire meteorology unit in an hour and a half, from heating of the atmosphere to communications and life skills. So yeah, I think we can just play this next year, guys, and get into astronomy day after a day.
Perfect.
Yeah, you
I will.
guys,
I'll say, and I mentioned this whenever we've got one of these hangouts and stuff that we do. If any of your students have questions that weren't answered here, or want to follow up on things or ask additional questions, you guys have our contact information. So feel free to send any of those questions our way, and we'll get back to them.
absolutely.
Thank you.
Thank you.
Thank you so much. We appreciate it.
Thank you. Thank
Well,
you.
Abington Junior High School students and parents, we hope you enjoyed it, and we hope you and your families are all well. All right, signing off. Bye, guys.
Bye.
Bye.
Bye, everybody. Thanks.
All right.